welcome to another Brookbanks Podcast. I'm Ben Wakeling, your host. With me today, I have Vivian, Group Director for Structural Engineering, and Devi Varatharajan, Senior Structural Engineer, both Brookbanks employees and both very clued up on transfer slabs, which is what we're going to be talking about today. Design, legislation, carbon reduction, and key takeaways for those listening who have a vested interest in this subject. So before we dive in, we'll do what we usually do and ask Chris and Debbie to give a short introduction to themselves. Chris, we'll start with you.
Thanks, Ben. Yeah, as you say, I'm Chris Vivian. I'm a chartered structural engineer. I have 30 odd years experience in the industry, a lot of which have been with multi-story residential type buildings, concrete frames, steel frames, etc. So have been involved in a variety of schemes up to and including 27-story towers. So fair selection over the years.
Excellent, thank you. And Debbie, over to you.
Yeah, thank you. I am Devi Varatharajan, a chartered structural engineer, and I have over 20 years of experience and I specialize mainly in RC frame structures.
Brilliant, thank you very much. Thank you both. So as I said at the start, we're going to be talking about transfer slabs. So for the non-educated like me, or minimally educated, tell me first of all, what is a transfer slab? Chris, let's start with you. Devi, please feel free to jump in.
Okay, I'll do my best to describe it. So basically, in an ideal world, multi-story buildings all line up from top to bottom. So if it was a block of flats, every floor plate would be the same. So as a result of that, if you've got concrete columns holding up a floor slab, they would line all the way through, and that's the most efficient way of making it work. In the real world, though, you have all sorts of other things going on. So you might have a car park or basement car park at the lower levels. You might have a retail space, etc., which has a certain layout. Obviously, in a car park, you need to be able to avoid columns when you're driving around, so they position in a certain way. Whereas above the first floor above the car park, you might have a residential set of flats which have a completely different set of columns. So as a result, the columns don't line up between ground and first floor. So you have what we call a transfer slab in between the two, which is kind of a super strong floor slab that actually transfers the load from above to below. Those floor slabs are typically, should we say, twice the depth of a standard floor slab and have significantly more reinforcement and are more challenging to design, but just part of the process.
So it literally is just transferring the load from the apartment building above or whatever it might be across the slab itself through the columns that are in different locations on that basement or that ground floor um, story. I think in my previous experience, it's always been basement car parks. I think has been the key driver for the basement slabs. I mean, why would you not just design so that the columns did feed all the way through, or is it just because they might not align to the purpose of that, whatever is below that transfer slab?
So, I mean, you'd be very lucky because in the car park the columns are positioned in only a very limited number of places for avoiding when you're driving around. For that to all line through with the layout above, you can guarantee there will be a column in the center of someone's kitchen or lounge or something above, and it's incredibly difficult to do a layout. It's being tried over the years, and sometimes limited success, but it's very difficult to line it all through if you have a different type of um, layout, should we say. And also, if you've got a commercial space, clearly the driver for that is to have as column free as possible. So you end up with larger spans, which make the floor slabs deeper. So if you then copied those larger spans throughout the building in the residential space above, you'd end up with a very inefficient design, putting a lot more concrete, a lot more carbon into the building. as opposed to sort of biting the bullet and actually having a transfer slab in place.
Um, Devi, is there anything you wanted to add to the discussion around the reasons for transfer slab?
I think basically Chris has covered it. So if you, as he said, like if you copy the same layout above, you're going to end up with a highly uneconomical design. So that is much more onerous than actually having a transfer slab, and it doesn't satisfy probably much of the client's needs. Like
And thinking about the design of the slab itself, again, from my, I look at it just in pounds and pence. You look at it in kind of millimeters and reinforcement. I mean, what would a typical transfer slab look like? You said it's double the depth of most floor slabs. It's reinforced. I presume it has like waterproofing on it as well if it's got podium landscaping above.
basically our typical RC slab, we aim for like a 225 slab with 6 meter column spacing. That works highly efficient, like in terms of the reinforcement requirements. But if you look at a transfer slab, we are looking somewhere between 450 to 600 or even 750, depending upon the number of stories it needs to support above. So
Yes.
it can be even 3 times thicker than the normal slab.
So it ends up being quite disproportionate to the cost of the overall frame. You're probably talking 30 to 35% of the whole frame is just the transfer slab
Mm.
because of the significantly more quantity of materials that you use, reinforcement, etc. So it's an expensive thing to have.
So presumably you would only really see transfer slabs in say city centre locations where space is tight, I guess, and you have to have a basement or some kind of commercial space because ordinarily, as you say, it's the engineering of a transfer slab is pretty hefty and costly, and so you'd want to try and avoid it, I should imagine, in a new project where you can, and that would, but you, but mostly you're forced to use it because of things like parking. There's just not enough space on the site to accommodate all the car park spaces that you need for that apartment block or blocks or whatever it might be. So, uh, is the first instance always to try and avoid transfer slabs or design them out, or
Absolutely. We like to be involved as early as possible in any scheme to see what we can do to try and design them out. But clearly, in the case of a car park, there's nothing you can really do with that. But having said that, there are ways of mitigating it. You can line up certain parts of the building that aren't necessarily all car park. There are ways of reducing the transfer slab down to reduce the material usage in the building. It's all about just getting in early enough at planning stage to actually to sort of influence the layouts and look at the sort of where the walls are going to see whether there's any commonality between floors. And it is surprising how much that can be done really to minimise the impact as much as possible.
I see. Uh, Devi, in our pre-podcast chat, yeah, you mentioned about there's an increase in industry attention on transfer slabs. It doesn't normally appear in the kind of publications I read, but it will do in the magazines and the articles that you guys as engineers read. So tell me more about that. Why has there been an increase in industry attention around transfer slabs recently?
Yeah, the Institution of Structural Engineers, mainly what we commonly refer to as ISTRUCTLY, released a piece of guidance towards the end of 2024 for the design of transfer slab. Basically, what is highlighted in the publication is like there is a gap in the industry guidance. Like we have the design standards to which we design a normal RC frames to, but when it comes to transfer slab, there was a gap in the standards, like how we interpret it to apply for the design of transfer slab. So this guidance try to unify, like try to fill the gaps between those and try to provide a more consistent approach for the design of transfer slabs through the industry. So this basically looked at like what the issues are around the design of the transfer slab and how it can be mitigated, and it gives like a list of guidance of how to go about it. So because this is a new industry guidance that is to be considered in the design of new transfer slab, this created a lot of um, attraction in the industry. Like everybody wanted to know like what this new guidance is about, and if your existing buildings need to satisfy the guidance and things like that. So that's why I think it is increasingly like everybody wants to know about it and how to make this transfer safer.
And it's you talk there about the guidance. Has that kind of transferred through to legislation? Is it just guidance at the moment? There's no kind of hard and
It,
fast legislation around
it
this.
is not a legislation at the moment, it is just guidance, but it gives you a new approach to the design of like the transfer slab. Basically, these transfer slab like heavy column loads, and the predominant punching shear failure is the predominant very critical mode of failure in this transfer slab, and it gives you a new approach to the design of punching shear. So that's why it is very very important, because this failure is sudden and can happen like very very quickly when the column loads are exceeded, and if you haven't designed the reinforcement around the slab to meet it, then the failure can be like catastrophic.
Yeah, I mean, I can imagine if a transfer slab is insufficient, that can go pretty wrong pretty quickly. Chris, you look like you wanted to come in there.
Yeah, I mean, obviously, that sounds dramatic, doesn't it? I mean, the building safety regulator back in December issued guidance and almost like highlighting a risk from this. And as a result of that, a lot of our clients have sort of, or in all the industry, are really asking the questions, where are our transfer slabs? And it's kind of got to the point where, it's become a risk item for a building. Now, there's no suggestion that the transfer slabs for the last 20 years haven't been designed properly. There's no evidence to suggest they haven't been. It's just, as Devi says, there's different, more conclusive guidance for everybody to actually produce their designs. The fundamentals are still the same. The way we treat shear and we treat bending in the slab is the same, and the loads and forces, they're all designed, you know, to a certain extent by finite element type software, which is very accurate. So we're in a bit of a strange situation in the industry where there's nervousness all of a sudden for something we've been designing for 20 years, and so therefore we're having to go back and sort of have our designs looked at by independent people, just to see that it's all fine. Um, but
Yes,
it's
and as you say, it is, and it'll be. You would hear of a shear failure in the news, wouldn't you, if a transfer slab failed, and
oh gosh,
uh,
yeah,
we've not heard of anything like that. But people naturally, I suppose, get a little bit worried and want
of
an extra
course,
pair of eyes and
yeah,
just want that extra kind of comfort that everything's been designed accordingly.
yeah. I mean, it's an important point that there's never been a failure of a transfer slab in the UK. So obviously that's the important point to make. It's trying to temper the discussion to a certain extent. Structural engineers, vast majority, all do a very professional job of designing these slabs and have done for many many years. And it's a fairly empirical approach. But um, yeah, I mean, obviously it's nice to have this sort of guidance, but it is only guidance. It's not legislation, as you say.
Hmm.
Nothing's come through. It may well be the building safety regulator takes things further in the future. Who knows? But it's something we're obviously very aware of here at Brookbanks.
And what's the thinking more then about carbon reduction, which is obviously a really important part of current construction methods and design and so on. Do transfer slabs play a part in carbon reduction on site?
Oh gosh, yeah. I mean, the amount of carbon you require to make steel reinforcement, the amount of carbon that's needed to make cement is phenomenal compared to obviously a timber structure. So you've got a situation where because these slabs are so much thicker. There's so much more reinforcement. There is a big carbon footprint for these types of structure. And I know we say they're unavoidable sometimes, but sometimes they are. And even cutting those transfer slabs in half by dealing with parts of the buildings that can line up column wise, you are significantly saving carbon in the building because concrete frames are not generally particularly carbon efficient. The only way is to save materials.
It sounds like we should be building all our high-rise apartments in timber then, from what you just said.
You can do.
How tall can you go in timber, actually? Just a complete aside, going off on one of my many tangents.
Gosh, I think I've seen some examples of up to 16 stories. I may be wrong on that,
15,
but
16 stories, yeah.
yeah,
Wow.
so it's doable. Some big lumps of timber, but you can do it. But
I wonder why that's not adopted more in the UK. Is that just people are concerned about it? It's not the norm, and so
I think timber has its own inherent issues. I think people will argue it either way. There are problems with settlement with timber when it goes under load. They do settle timber buildings, which can cause issues with detailing, etc. Um,
And fire is another issue. Yeah.
Fire, obviously, very
yeah,
combustible,
of
but
course.
that's very much the case. But yeah, every material's got its pluses and minuses, I suspect.
So let's get back to concrete then. Get back onto solid ground. No pun intended. Sorry about that, everybody. The challenges of actually building transverse slabs then on site. Um, uh, what are they? You've got to build to the right detail, I suppose. Obviously, are there any other kinds of things that people actually building and forming transverse slabs on site need to give some thought to?
So yeah, I mean, transfer slabs aren't always low down. They can be 10 stories up in the air. And obviously with concrete, before it sets, it's just really, really heavy liquid. And so when you're talking about um, something that high up in the building, it does load the structure below it um, more than people expect. As you build a concrete frame, you tend to prop the floors below to take account of the wet concrete being poured above. But if you've got a half a metre concrete slab going in, you have to strengthen the floors below in order to take account of the temporary load of the floor. Because once concrete goes off solid, it spans, it does its job, it spans between the columns and it all works as intended. But it does create some challenges. Certainly if you've got buildings, for example, that step in as you go up to the higher levels and the columns don't line up because the walls don't line up because they come in, you might end up with issues there with high placed transfer slabs. And it's incumbent obviously on the engineer to design the structure for that temporary case as well. So yeah, there's a few challenges with it. The amount of concrete sometimes you need if you've got a 750 thick concrete slab or thicker, the amount of physical concrete you can get into the site to pour some of these slabs can be challenging at times. Um, where you put the construction joints is a really important factor in the design as well, where they start and stop the pour. Sometimes that sheer amount of concrete can create heat, maybe not 750, but thicker, can actually create heat problems with the concrete because of the chemical reaction of the actual mix, which can cause sort of cracking that we don't want in the structure. So there's all sorts of bits and pieces, should we say, that we have to consider
Blimey.
that we wouldn't normally consider with thin slabs.
I think the another main thing which I think Chris touched upon is like when you remove the formwork too soon, like no, in a normal concrete slab, like they have the formwork for say 2 weeks. By the time it's like it has achieved like certain amount of strength. But with with the transfer slab, because it's thicker, it takes time like to get the full strength. If you remove the formwork too soon, then it can lead to large deflections, and your whole load path can get changed. So all your design assumptions may not be valid. So it is more important that that needs to be considered in the construction sequence, the propping sequence, that has to align with your design assumptions. So that is a tricky bit with the transfer slabs.
Yeah, there's so much to think about that it blows my mind. I um, naively thought it was just a case of putting the formwork in, throwing in the concrete, and waiting. But there's so much more to think about, and I'd not even considered transfer slabs at being at a higher level before. I always just assumed they were at the kind of ground or first floor level. But pouring a transfer slab, say 10 stories up, and making sure that everything below it can hold it up, and considering things like heat and all that kind of stuff. I mean, surely you would, again, my simplistic view, you would, if you were designing a building that was stepping in as it went up, you would still design it so that the columns just carried on through. But maybe that's me being with my logical brain and not being very creative and thinking that everything should just be nice and square and
No, no,
and
you're
quite
absolutely
boring.
right. You're absolutely right. But it's all about getting in early enough to make those informed design choices. That you can do it. You can kind of build in redundancy in the upper floors by just moving columns a little bit around or walls around at the ground floor when you're
Mm,
sort of thinking ahead, if you like, in order to mitigate an awful lot of this, especially the edge columns, which are the sort of one of the worst ones to deal with. So yeah, it's about getting in at planning stage and seeing what steps they're putting in the building. Do they need the steps? Can we value engineer out some of the steps so that they don't, you know, they don't cause a transfer higher up? Or if they are steps, they're right at the top of the building rather than halfway up, sort of thing.
yes.
End of the day, the architecture will be what it'll be. We're not. If you ask a structural engineer to design a building, it'd be very rectangular and rather boring, I suspect. But it, it's just things like that. It's just the commercial aspect of it, I suppose, doing the concrete.
It comes back to a theme that crops up time and time again on this podcast, which is getting in early and really giving some proper thought and time and energy and resource into design is it will pay back dividends later down the line, and quite rightly and understandably, developers and contractors and everyone else are quite keen to get on site and get building and see the fruits of their labor. But giving that extra pause, that extra bit of thought early days is really key. I mean, as we begin to kind of come to a close, are there any other kind of key factors that we need to think about as designers or contractors or whoever it might be in terms of transfer slabs?
I don't know what you think, Devi, but certainly one of the things we obviously always deal with is M&E integration. Um, Obviously, columns are brilliant for putting rainwater pipes, cable trays, and that's the logical place where you put a lot of services. But it's the worst place to put services on a transfer slab because inevitably, when you've got a rainwater pipe alongside a column, the hole will go straight through the slab next to the column, and that has a significant effect on the integrity, well, not the integrity of the transfer slab, but its ability to work, and means adding a lot more reinforcement sometimes to counteract it.
Yes, because that hole presumably is like then becomes a weak point in the transfer slab, does it?
Yes, yeah. So you've got the interaction of the column and the slab interface, if you like, and there's a perimeter around the column which holds up the floor slab. And if we're not careful, there might be 3 or 4 holes dotted around the perimeter. Sort of there'll be no concrete left to transfer the load from the column to the slab.
It's like perforated paper, isn't it? It's like if you push down on a piece of paper that's got perforations all around it, it's going to break at those perforations, isn't it?
Exactly, exactly. So yes, we have to check every single column. We check every um, eventuality. So that's part of our responsibility and remit to make sure that happens. But talking about efficiency, talking about carbon again, we're just by moving a rainwater pipe a meter to the left can save half a ton of steel or something, being maybe over the top. But I don't know what you think, Devi. But
Exactly, because the slab is working really, really hard in with a transfer. I think it may like moving the openings around will make a massive difference to the design.
Absolutely. Excellent. So if someone is listening to this then and they've got a project that's in the early stages and they know they're going to have a transfer slab, um, or maybe they don't, what would be the kind of key takeaways for them from our discussion? What would you recommend that they do next. We'll start with you, Chris, and then head over to you, Devi, and then we'll finish from there.
I think there's a lot of chatter in the industry at the moment about transfer slabs and about the risks associated with them. But it's about just following the guidance, following the you know the principles that have been around for 20 years, so that we shouldn't be put off doing them. Clearly, there's a commercial and a carbon aspect to them. If you've got to have a transfer slab, that's absolutely fine. They can be designed very, very efficiently. We're doing 2 projects at the moment that have got transfer slabs, and it's part of our day-to-day work, shall we say? So not be put off, I think, is my thoughts on it. But if we can get in early enough, if we can look at the building and find ways of reducing it or removing it altogether, then all well to good. That's really the best I can suggest.
Excellent. Devi, over to you.
I think I would like to reiterate what Chris has said. Like, we shouldn't be put off designing transfer slab, but then getting in early gives us a chance to review the options thoroughly. Sometimes we can reduce the extent of the transfer by discussing the options with the architect and the other stakeholders of the project. So that can have a big carbon reduction and the overall reduction in the cost of the project. So yes, it is doable and we can do it as efficiently as possible, but just need to get in early in the project.
Brilliant. Thank you both. If anybody listening wants to get in touch, what's the best ways to get in touch with you? Devi, we'll start with you this time.
Um, just contact us through Brookbanks or through a LinkedIn profile.
Thank you. And Chris?
Same again. Obviously, email or LinkedIn or via the website. More than happy to
Excellent.
have a chat.
Thank you. And the website, for anybody who doesn't know yet, is brookbanks.com. You can contact myself, Chris, or Devi, or anyone in the team through the website there, and we'll come back to you as soon as we can. So, remains for me to say, both Chris, Devi, thank you very much for your conversation, your input, and your experience. And we will see you next time for another Brookbanks podcast.